Hello, this is Ryan Woodward recording for Intel's Digital Logic course through FPGA Academy. This is Lab 1, Part 5. And in this part, we needed to leverage the BCD decoder we did in Part 4 and the 2-bit wide 4-to-1 multiplexer we did in Part 3. And we actually had to make 4 instances of each of those circuits in this specific circuit. Here is what it's supposed to do per se. We can see that we have our MUX with the 2 selector switches, and that connects to the 7-segment decoder, and that allows us to display the characters. As you will have seen in the BCD decoder circuit, basically the characters we're looking to display are DE 1 and 0 to represent the DE10 light board that this is all being built on. And we need to build this so we have 4 displays, and it allows us to toggle these 2 switches, 9 and 8. And essentially what we want to see is that on those 4 displays we see the word DE10, but as we toggle those switches it will go from DE10 to it'll be E10D, then 10DE, and then 0DE1, and it's basically making the word cycle, or kind of this circular motion it kind of would be as it kind of cycles through from each hex display. But that's the ultimate goal for this circuit here. And for VHDL, I removed the portions in the Intel code that they provided in the lab document where we declared the extra entities for the BCD decoder and the multiplexer, because I have those already in my project. These are here, and these are the same circuits from before. But I just didn't include them in the single file. Rather, I just went for, even though it says behavioral, I went for a structural modeling where we include these components here in this VHDL file. For this specific portion, and this is straight from Intel's documentation, or the lab document rather than my own code, at least this portion, I added these 3 hex displays, but they provided hex 0, the LEDs, and the switches. Admittedly, I don't like that they lumped all the switches in here, because we have, for this multiplexer, we have these 4 2-bit inputs that basically we could pass to the output. And I think it'd be far more helpful, more clear for us, or people who are less familiar with VHDL, to see that what switches are specifically going where. And it's very tough if we were to look at these port maps down at the bottom, and this first one is actually from Intel here. It's very tough to see what switch we're trying to interact with here. Where is U? Where is V? Where is W? Where is X? Well, we'd have to look specifically at our port map to know that, whereas if we were to rename these and just maybe dish them out 2 bits rather than the full 10 here for this single switch, maybe we were to have switch underscore U, switch underscore V, etc., we could clearly show which switch is which, or which pair of switches is which. And that way it'd be it's more readable. And I think that's a better practice rather than this they lumped them all together in one declaration here. It's kind of nice that they're all lumped together, but it's less readable. And that would be my only criticism there. But there are a few intermediate signals that served as the outputs for the multiplexers, and these end up getting passed to the hex display right away. So after these are processed, the hex display receives that output, that 2-bit output, and then that decoder passes that on after it's decoded to the hex display, which we can see hex 0, hex 1, hex 2, and hex 3 as we declared above here. Those are the 7-segment displays we'll be using for this circuit. And what is interesting to note, as the goal was to have that kind of circular nature for that DE10 word, and the way we accomplish that is by actually allowing these switches to change positions here. We'll see value 98, 98. This value essentially would be U in this instance, and we're passing U, which, if let's say this were the value 0, 0. If it were 0, 0, and that's what's selected to go to the output, then we will see a D. But in this instance, we see that this switch now is 7, 6. And that one in the first instance should be 0, 1, which is an E. And then below we see switch 5 to 4. That is the second pair of switches, as we can, or excuse me, third. We can see from here 5, 4 initially was W, but it's now U. and as we can see here, the first port map is U, and that should be a 1, because at that point those switches should be a 1 and a 0. And if I remember correctly, the truth table is 0, 0 to be D, 0, 1 is E, 1, 0 is 1, and then 1, 1 is 0. And so this allows us to have that rotating effect on those hex displays, is that we actually have this move back down to the right, then this moves up 1 to the left, then back, and the other condition will allow us to return it to the front there. And that's it. It's not all that complex, but it is a bit to get all this straight in our head, especially with the switches not being clearly defined. Like if this were switch U, for instance, if we were to change it like this, we would see that switch U is getting rotated around pretty easily. It's a lot more easy to define there. But alas, we don't do that. All right, and here is the Verilog. One thing I do love about Verilog is that it feels a lot more like C, and it seems to be that I generally can use a lot less lines of code to get Verilog up and running. But this is essentially the same thing, and I didn't bother showing for this project actually leveraging the Verilog circuits I built for the BCD decoder or the multiplexer. They're both very straightforward, and once you have something in Verilog or VHDL, I think it is very easy to basically translate it over, and that's simply what I did. Is I borrowed some of the code from Intel, which gave me all the ports listing here. As you can see, these are their comments from their lab document. They gave me the intermediate wires. Well, they gave me one of them. I had to add on, and they gave me the first, this first line here, and then this first BCD line there. Had to just copy and paste the rest and just change some of the values so that it would work. We can see that the LED is being assigned here. I did do that in the VHDL, just a brief moment. I don't want to forget that I displayed that. Here it is right there. But in the Verilog, I like that it's a lot more succinct. But just before I end here and go to the demo, I do want to show that we're seeing that similar rotation for each of these. And that's really important if we're going to accomplish this the same way. And although I'm going to perform the demo in VHDL, I will perform simulations and test this on my own to verify that this actually works. But that's it. All right, and here's the demo of the rotating DE10 word. This is the hex characters. And so we can see that we have a few switches high, indicated by our LEDs there. And I actually messed up a little bit. So rather than having D displayed when both are low properly, we can see that D starts on the end. Which is no problem, because if we were to flip one, we actually see that it's proper. But rather than flipping it up and actually counting from 0, 0, 0 to 1, then 1, 0, then 1, 1, we just have to start in the middle. So at 0, 1 is where we start. And if we were to flip to, this would actually be 1, 1, we'll see that DE flips left here. So now we've moved one character over. If we were to flip this down, we see that DE moves over again. And if we move this back up, we will see that D flips all the way back to the end. All right, and that's it.